Hi, hi.
Hi,
Good morning.
good morning. Sorry, good evening for you guys. One moment, guys, will stop. Okay. So, guys, in the next couple of classes, we will be talking about terminology and services.
Okay.
Understanding this terminology and service is very important, guys. So, let's get started. Okay. Actually, guys, when we're talking about data centers, basically, all the IT infrastructure happens or runs only with the data centers. So, every organization should maintain a data center. And when we say data center, it is nothing but a physical location where our server resides. Okay. Now, guys, what is meant by server now? So these guys, you should talk. Okay. The more you talk, the more I can explain to you guys. Okay. So server. When I say server, what is a server? So server is nothing but a hardware which has a RAM, which has CPU, which has a network, and which has disk. Okay. So on top of this on top of these resources, that is RAM, CPU, network, and disk, we basically install the operating system. So the operating system could be Windows or Linux. Okay. So when after installing is Windows or Linux, the same box, the same server, if it is having Windows, then we will be calling it as a Windows server. If the same server is having or Linux in operating system, we call it as a Linux server. Okay. And on top of these operating systems, if we are installing our applications, say applications could be your SAP applications, your DB applications, or any other application now, then we also can call these servers as a SAP server, a DB server, or application server. But altogether, when I say server, is nothing but a box, a server which has all the operating system, applications, and all. Okay. And when we're talking about data center, now one data center has a 50 to 1 lakh such servers. They physically maintain that many physical servers in one single data center, and they start publishing their applications and they start using their applications. So Amazon is maintaining such data centers, around 46 data centers all across the globe. So in globe, where are they actually present? That is nothing but the regions. So Amazon calls it as regions. So they have streamlined this in such a way that altogether there are around 15 regions, and in each region there will be minimum of 2 availability zones, 3 availability zones, or maximum of 5 availability zones. Okay. So guys, when I say region, it is just a location where your data centers are present. But these are not the actual data center. It's a location, that's it. So in the location, I can say that in US, there are actually 4 locations. One is Ohio, North Virginia, California, and Oregon. These are the 4 locations, 4 regions where Amazon has put their data centers in US. And we have one in Mumbai, one in Singapore, and one in Sydney, and one in Palo Alto. Like this, there are 15 regions. And region is just a location, but the actual data, the actual servers are again present in the availability zones. So when I say availability zone is nothing but your actual data center. Okay. So this region could be what? Now whatever I said, North Virginia, California, Ohio, Oregon, it can be any region now, but in every region there will be minimum of 2 availability zones. So availability zone is nothing but a data centers. So why Amazon is maintaining 15 regions, and in each region why they are maintaining 2 availability zone, guys? Because of the high availability and fault tolerance. Because in IT and all, we providing high availability and fault tolerance is a major challenge. And how are they going to give this high availability and fault tolerance? This is because when I am talking about a data center, there are a lot of components which are required for a data center to run, such as the power supply, uh, internet provider, ISPs, maintenance, cooling, monitoring, everything comes into picture. So when one data center is being monitored or all the sources are coming from a source X as an example, the other data centers within the region will be receiving all the other sources from the Y. In case if X sources are failed due to some any reasons, my still our second availability zone will continue to operate normally. So failure in one availability zone is not going to impact the other availability zones. And this is why they have put 2 availability zones, minimum of 2 availability zones in one region. Then what is the purpose of having multiple regions now? Instead, Amazon has put a big data center in only US, and they could ask all the users across the globe to connect to this US data center. But instead of this, what they have done is that they have established 15 regions: Mumbai, Singapore, Australia, Sydney, all these things. What is the purpose of it? The main purpose of that is that to reduce the latency. It means that if your servers are situated in US, you're sitting somewhere in India, and you are putting all your resources in US, and the only way that we can connect to our cloud services is over internet. So accessing your services over internet with a very long distance would actually cause a latency issue. Latency in the sense delay. When I say latency, guys, remember it's nothing but a delay. So delay in responses will be there because they are geographically separated with thousands of miles away. So to reduce the latency, what Amazon has done is that Amazon has placed data centers all across the globe. Say Mumbai, Singapore, German. So if guys are logging in and around Singapore, they would prefer to store their applications in the Singapore data center. If guys are logging in from Germany, people would prefer to put their data applications or data in the nearest data center, that is nearest availability zone or nearest region. So in this case, they would be nearer to the data center and there won't be any latency in the accessing of your servers. So that is the reason to reduce this latency, Amazon has placed these regions all across the globe. Clear, guys?
Yeah.
Yes, yes.
So, and Amazon AWS region is a physical location spread across globe to host your data to reduce latency. In each region, there will be at least 2 availability zones for fault tolerance. And remember, guys, these availability zones are connected to each other with a very high bandwidth network, that is 25 Tbps. The connection between these availability zones is 25 Tbps. All these are connected with a 25 Tbps of bandwidth, which is very huge. And availability zone is combination of one or more data centers. So guys, region is just a location, a geographic location, and within that region we have our data centers. So each data center is nothing but one availability zone. and these are not separated by kilometers. So guys, when I say that within one region, say Mumbai, if they say that they have two availability zones, it's not that these data centers will be separated by kilometers. They are within one single compound wall and they are just meters away. That's it. They are separated by meters, not by kilometers. And failure in one availability zone will not impact the failure in the other availability zone, and other availability zone will still operate normally. And it has a connection of 25 dBs of bandwidth. And the data center, a data center is a location where actual physical data resides. A data center typically have 50,000 to 80,000 physical servers. So Amazon would have clubbed one or two data centers to make it one availability zone. So we are least bothered about it, but we are only bothered about the availability zones. So here we are not going to maintain any of the data centers, and Amazon maintains it. Edge location, guys. So when I say edge location, just now I told you that there are 15 regions, say US. Now let's start example of only two things. And India, in India we have Mumbai, and let me take one more thing, say Sydney. These are the three regions which I'm talking about now. So guys, I'm a blogger. Okay, I'm just starting my own blog, and I have my own blog, and so I have moved all the data and everything to Amazon because Amazon is giving me good service. So I have placed my server in Amazon, and I have some data there. So this web server is running on this data, and fine. So everyone is accessing, say, mycloud.com. This is the site, whatever it is. Okay. And people are sitting somewhere in Sydney now. People are sitting somewhere in US, and they are reaching out to my server. But in the previous session, in the previous class, in the previous slide, I told you that if my data is available in one region, people are accessing from other regions over internet, they would have a latency issues, guys. So now, here my data is present in Mumbai, but people are accessing across the globe, and they are able to contact my website, and they are facing challenges. So when they are accessing it, there is a delay in the response. My website is opening very slow. They are unable to read the content properly because of the slow performance of these issues, because these guys are accessing from a very long distance. So in this case, how can I overcome that? So to overcome such situation, I have two things. One is put the same kind of data, the same kind of servers in the other region so that people will not face any challenges. And user, whenever they are requesting, the request would be sent to the nearest site, the nearest data center. But to do this, if I'm paying $100 here, I should do the same thing here. I also pay $100 here. Then I'm just a startup guy, and I cannot invest this much of money just to serve my people, to serve my guys whoever is accessing this. So this is going to be a costly solution. So to overcome this, Amazon has a solution called CDN. CDN is nothing but Content Delivery Network. So it is not a new technology, guys. All the Facebook, Google, any major sites you take, they maintain their own content delivery network. What they do is that their actual data still presents in the same data center where it is, and they have edge locations. Okay? And these edge locations are present almost in all the major cities across the globe. With this edge CDN, what I'm going to do is the data, whatever I have in my website, I'm going to send it to my edge locations. So these edge locations are not the availability zones, but these are the cache sites. These are called as a cache sites. Okay. So now I don't have to put my infrastructure here and here. Since my data is already sent to the edge locations, when the user is trying to log into my own domain.com, the request would be sent to the nearest edge locations. So without any latency, now he will be able to access the servers. Okay. And in India, we have these two edge locations, one in Chennai and one in Delhi. And our data centers are available in Mumbai. So like this, every region you take across the globe, they have a data centers. Edge locations. So this is how edge location functions. Now, which service is allowing us to send the data from our origin? So wherever our actual data is present, we call it as an origin. From origin to edge locations, we are sending the data by using a service called CloudFront. So CloudFront is a service which we use to send the data from the origin to the edge location. Here, guys?
Yeah.
Yes, yes.
Direct connect. So anything we are accessing in AWS region, say Mumbai, US, or anything you take, and my office is somewhere situated in Hyderabad or any other location apart from North Virginia, California, and you have a lot of services running in AWS, all your infrastructure is running in AWS, and you have lot of users also who are connecting from your on-premise things, and they're accessing your servers, but every communication from your office premise to AWS region is happening over internet. So guys, internet, internet doesn't give us the proper speed all the time. It has fluctuations and it is not adequate. Sometimes the disconnect happens, frequent disconnect happens, and people are facing challenges in accessing the resources. They are accessing very slow because of the internet connections. So to overcome such challenges of internet, what Amazon has done is that Amazon has a concept of service called direct connect. What this direct connect is going to do is that they are going to physically lay a optical fiber cable connection from your office premise to your AWS. So this is not internet, guys. Remember, this direct connection is not an internet connection. It is just a physical connection. With the physical connection, you guys sitting in office will be talking over the dedicated connection to your resources. So this will actually reduce the cost of your internet, and you don't have to rely on the internet connection to communicate. This is going to act as a private connection to you. So imagine like you have one office in North Virginia, you have other office in California. So you don't have to talk over internet. They'll be having a lease line. With the lease line, the dedicated connection, they talk over to the other resources. The same way, now Amazon and your office premise will have a dedicated connection through which you will be able to receive or talk to your resources. That is what an actual direct connect is. So this service, not everyone uses this. If you require this, you can use this. So an AWS Direct Connect is a service offered by Amazon for dedicated optical fiber cables from your office premise to AWS. So the advantages is to provide an adequate and dedicated bandwidth to your services located in AWS. It is going to reduce the latency from your network to AWS, and it's like a private connectivity to your services in AWS from your office premise.
So is it like a physical connection?
Yes, it's like physical connection. It's a physical connection only. When I say optical fiber cable, OFC, it is a physical connection.
So
just like now, say you have
it's
you
like
want to take
cable service. Cable service in like we have less
exactly.
cable service.
When you want to have an internet connection, what happens? That guy is going to
Pull one wire.
pull a cable to your home.
Yeah.
Same thing.
Oh really? Okay.
Okay. An endpoint. So endpoint is nothing but an URL through which we will be able to access the services. URL like aws.amazon.com or your own company.com/amazon.com, like this, whatever the URL that we define to access services, we call it as an endpoint. So guys, now when we're actually talking about cloud, we talk about four main things: the scalability, fault tolerance, and elasticity. Okay. So in your terms, I would like to know, what do you mean by scalabilities and fault tolerance? So do you know what is fault tolerance first before talking about scalability?
Yeah.
Any idea about fault tolerance?
Not much.
No.
Fault is a defect, tolerance is overcoming the defect. Okay. Okay. We are running a services. Basically, I'll tell you. I just told you that we have a physical servers. So I'm just talking about two physical servers just to tell you how this fault tolerance is going to work. And we have our hardware. And we have our operating system. We have our application. And here also the same thing. Hardware, OS, application. So guys, when I'm talking about the hardware, I just told you that we have a RAM, CPU, network, disk. Apart from this, they have a power supplies, HBA cards, and NIC cards, any other module. So it is a physical server. Due to any reason, my power supply might go bad, my NIC card might go bad, my other HBA cards might go bad. So when they go bad, actually, my application is not going to work properly. And I'm running a business critical application. That means my pay system, my payrolls are happening on this respective application. If this application is down for 5 minutes, it is going to lose me some $10 million. As an example, I'm just telling you. It is going to lose me huge loss. So I should make sure that this service is up and running irrespective of the failures. No matter if RAM corrupts or disk fails or CPU fails, my application should still run. But it has failed now. So when this has failed, how can I make it highly available? So I would have planned for that before the failure happens, that okay, if this server fails, I need to have the other server configured. If this application is down, my application still runs on the other node. So guys, node, host, physical server, everything is the same. Don't get confused. So my application might be running in the other node. So this is kind of fault tolerance. Now, where is this physical server running now? This physical server is running in a data center. So due to some reasons, my server is fine, but due to some reasons, my entire data center is down now. In this case, it is going to impact not only one application, it is going to impact all the services in one single data center. So how do you overcome this? That's the reason Amazon has put a minimum of 2 availability zones, that is 2 data centers in one region. So whenever you are designing your infrastructure, you should always deploy any application that you deploy on one availability zone should also be deployed on the other availability zone. That means even if your availability zone goes down, your applications are still running on the other availability zone. And these are running in a region now. These are running in a North Virginia region. And there was a thunder in North Virginia. Because of the thunder, what happens? The entire region is down. What if the entire region is down? Their active instances, their standby instance, everything goes down. Then they would have planned for a DR site, which means that they would have put their data center somewhere in California, and they would have run. So this is the kind of things that we need to think when we are actually planning. So when you are planning about a fault tolerance, irrespective of the failures, our application should run. If you have designed this thing now, no matter what happens to your data center, your application will still continue to run without any downtime. So that is what a fault tolerance, ability for a system to operate without interruptions in the event of a service failure. Is this clear, guys?
Yeah.
Yeah.
So to build that environment, to build that highly available and fault tolerance environment, we could use some services such as auto scaling. We'll talk about this. A Route 53 availability zones and multiple regions. You should always include these four components to make your infrastructure highly available and fault tolerance. Okay, this is what a fault tolerance. Now let's talk about scalability. Say I'm running a web server. I'm running a web server on-premise within my own data center. I'm not talking about cloud now, or within my own data center, or let's say cloud as well, no problem. So my web server, say Amazon.com, a retail site of Amazon.com, I'm maintaining. I'm the guy who is maintaining their site. So they have started their site with two servers, which means that let's say suppose these two servers can accommodate some 2000 users. That means at any point of time, only 2000 users can access my website. If the requests are going beyond 2000, my server would perform very slow and they will not give me proper pictures, will take time to load and all like this. And now the demand is going from 2000 to 4000. Now in this case, what should I do, guys? Launch additional services which can have more servers. Now since two servers can accommodate 2000 users, for 4000 users I would launch additional two servers. Now altogether it comes under 4000 users. So this is what the scalability. Based on the demand, we are able to provision our servers to overcome our demand. That is what a scalability is. So in cloud environments, the more you scale up, the more cost effective it becomes the moment you grow, because the price is going to be reduced the moment you launch more services. And elasticity. So what is meant by elasticity now? So scalability means I told you that we are able to expand our infrastructure on demand. But how about the elasticity? Okay.
Like
So
flexibility, I think.
yeah, flexibility in what terms?
As you said, like now, if you want 2000 users, you can use two servers. If you want, you can use 4000 users, right? Whenever we don't want, so we can reduce the servers, and whenever we want, we can increase the servers.
Exactly. So that is what an elasticity is. So increasing of servers on demand and decreasing of servers off demand is nothing but an elasticity. Okay. So as organizations calculate this elasticity in terms of few things. So let me tell you. So I'm just running an Amazon, and Amazon by default, like I said, it has 2000 users all the time. Amazon says that, boss, I always have 2000 users who are accessing my website, so make sure that my web servers are able to accommodate 2000 users. Then as a guy, as system admin, I'll make sure that, okay, so since it is 2000, I would provision two servers. One server can accommodate 1000 users, so two can accommodate 2000 users, fine. But this guy tells me that, see, though there are 2000 users daily, but there is a certain time, that is from evening 5 p.m. to some say around 10 p.m. PST, IST, or sometime, let's say. So during this time, during this period, every day they expect around 5000 users. Because guys, Amazon is they are selling products on website. So 5 p.m. to 10 p.m. everyone comes back to home from offices. So they are idle. So they start browsing the site. So during this time, they have a more demand on their web servers. That is 5000. This happens daily. So now I should understand that, okay, from 5 p.m. to 10 p.m. I should be able to accommodate 5000 users. So to accommodate 5000 users, what will I do? I will provision 5 servers. But it doesn't make any sense in provisioning 5 servers all throughout the day just to meet up these 3 hours of requirement, right? All throughout the day it should be only 2 instances, but when the time strikes, that is 5 p.m. to 10 p.m., my 2 servers should go to 5 servers. Okay, this is one criteria. The other thing is that Amazon also says that every month we put an offer every third week. Every third week, that is every third week weekend, say 21st and 22nd, Saturday and Sunday, they put more offers. They put some offers in their website. So in this only every month from 21st to 22nd, they expect around 10,000 users. So in this case, I provision around 10 servers. And these 10 servers has to be provisioned only for 2 days, all across the month. That is to on only 21st and 22nd. So got my point, guys?
Yes.
And user also says that boss, everything is fine, but nowadays I'm also seeing some increased demand from 10 p.m. to 4:59 p.m. Even between these also, sometimes I see more users coming up, and I see the requests are not happening. That means during this time I will say that okay, this is he doesn't know the time, actual time when it is happening. Randomly it is users are accessing it more than 2000. So I would say that okay, if they are having more instances, I already have it 1, 2. When there is a demand in this, as per the requirement, launch 1 or 2 instances. These are the 3 situations what we have. So I can say this 5 p.m. to 10 p.m. as a known peak periods, that is proactive cycle scaling. And I can say this 21st to 22nd as an event-based scaling, where a event happens once in a while. And this 10 p.m. that is 10 p.m. to 4:59 p.m. is nothing but on demand. So the demand, I don't know when the demand will come, but when the demand comes, my infrastructure should have intelligence to provision the additional servers when and then required. So these are the 3 things, guys. One is scale out based on a known peak periods. These are the known peak period, that is 5 p.m. to 10 p.m. So before the time strikes, you will provision the servers and you give it. And proactive event-based scaling. So scale out in anticipation of increasing demand. So this is the demand every month from 21st to 22nd, demand increases. So based on that, you will make your infrastructure ready. And after 22, you will scrap all the unwanted instance and you will come back to the normal stage, that is 2 servers. And auto scaling based on demand. How can I define that there is a demand? Okay, I already have only 2 servers. When the users are increasing in this respective server, I'll say that CPU is there, right? CPU will increase automatically. When the application is being accessed by multiple people, my CPU will increase. Then I would say that if my CPU is greater than 80% for 15 minutes, then I understand that, okay, there is a demand on the server. Then I would say add 1 more server. So my monitoring tools will monitor for the CPU usage all the time, and if they find that CPU is 80% for continuous 15 minutes, then the instance is launched. This is on demand. And I will write a 1 more rule saying that if my CPU is less than 40% for 1 hour, if it is less than 40% means the demand is less, then I would say that remove of 1 instance whatever you have launched. So I don't have to be there, sit there in front of the machine and provision servers on demand. It is all taken automatically. Okay, so like this we do in terms of your uh, on demand. Scale out based on metrics such as CPU utilization, network utilization, etc. So guys, this scaling of these instances is happening in 2 ways. One is horizontal scaling and vertical scaling. So what is meant by horizontal scaling now? What is meant by vertical scaling? So guys, it is very important that you understand these terms. So here we have started with 2 instances and we have ended with some around 10 instances. This is what an horizontal scaling is. That means launching your instances on demand is your horizontal scaling. And not all applications support this, guys. And the best examples are your web servers. So web servers are the best example for your horizontal scaling. And vertical scaling is increasing the resources of your servers. You already have one server with say 2 GB of RAM and some disk of 100 GB and 2 CPUs. But user is complaining you that it is not performing up to the mark, it is very slow and all. So in this case, you actually increase the CPUs or increase the capacity of the instance. You will not launch a one more instance, but increase the size. From 2 CPU, you may make it 4 CPU as per the requirement. You may make it 8 GB. You may increase the size to 200 GB. It is only one instance now. Earlier also one instance, now also it is only one instance. This is what the vertical scaling. The examples are databases. So databases are the best example for this vertical scaling. Okay, guys.
Okay.
Okay. Yes, sir.
And AWS services. So these are the services that AWS is offering, guys. Compute and networking, storage and content delivery, database services, analytics, app services, deployment services, and management services. Okay, so these are the combination of all the services Amazon is offering us, and we will be talking about these things one by one. So compute and networking services. AWS provides a robust offering of compute and networking services. So guys, when I say compute, remember compute is nothing but RAM and CPU. Okay. When I say compute, there are basically four things: compute, network, storage. Compute is always RAM and CPU. It's actually CPU and RAM. Network is something like networking only. When I say storage, is nothing but the disk that we attach to our virtual machines. So now we are not talking anything about the storage part. We are only talking about the compute part and networking part. These services have a different use cases depending on your application type, build, and deployment methods. So in computing, Amazon is giving a service called EC2, that is Elastic Compute Cloud, which is mainly responsible of provisioning your virtual servers. Okay. So before we talk about these things, and I want you guys to be very sure about what is meant by virtual server. Guys, what is this virtual server? No idea. Okay. I just told in the beginning that we have a physical server. Physical server has hardware, that is RAM, CPU, network, and disk. On top of that, we install our Windows or Linux operating system, and on top of that, we can install any application, say SAP, Oracle, or any other application server, whatever it is. So when we're actually calling this server, we can say that it is an SAP server, it is an Oracle server, it is a DB server, it is a Windows server or Linux server, like this we'll call it. And I can also call it as a SAP node, Oracle DB node, or application node, or like this I can also call it. This is a traditional way of doing your things, guys. But virtualization has come after this. So this virtualization has changed the picture of this server. So it will be like this. You already have a server which already has a RAM, the same thing, CPU, network, and disk. On top of that, we are going to install the hypervisor. So what is hypervisor, guys? This hypervisor is nothing but a virtualization software. Virtualization software. What does this do is that it is going to virtualize your physical resources, and it will allow us to create a multiple virtual machines within a single hardware. So when I'm talking about a virtual machines, that virtual machine will have again a virtual hardware. When I say virtual hardware, it is nothing but a virtual RAM, that is VRAM, vCPU, virtual network, and virtual disk. Everything is virtual. Whatever the physically we have, those things are converted into virtual components and given into virtual machines. And on top of the virtual hardware, again I am going to install my operating system, Windows or Linux. Again on top of that, I am going to install my application. It's like now this complete set of box what I have drawn here is going to be a virtual machine on one of the physical server, and it has everything. We call it virtual RAM, virtual CPU, virtual network, and virtual disk. Okay, this is how now most of the data centers are built, because without virtualization there is no concept called cloud. So all your servers are virtualized, and now this virtual machine we call it as a virtual server. So I can call it as a virtual machine, I can call it as a virtual server, and Amazon calls it as an instance, a Windows instance or Linux instance, because most widely this operating system is going to be Windows or Linux. Okay. So what is an hypervisor now? Hypervisor is a virtualization software which virtualizes your physical server. So who are the vendors we have? We have VMware. We have KVM. We have Hyper-V. And we have Zen. Zen is an open source one. So these are the vendors we have. But Amazon uses Zen as the hypervisor. This is what the hypervisor they use is Zen. On top of that, we are launching our virtual machines. These things are taken care by your EC2 thing, Elastic Compute Cloud. So when you talk about Elastic Compute Cloud, we mainly talk about your virtual servers, that is instances, running on top of it. Any questions?
Can you explain me this virtual server again? Can you repeat this?
Okay. I'll give you a different example now, so that you actually correlate this. You already have a laptop. Everyone holds a laptop, right? Everyone has a laptop. And every laptop has got some Windows operating system, Windows 10. Okay. As a part of your project now, you have to demonstrate something. You have to deploy an application. You have to test an application on a Linux server. Okay.
Okay.
So having your Windows 10 PC, desktop laptop, and now you should test your applications on Linux. How could you do this?
How could you do this?
How can you do this? How can you work on this now? Options I'll tell you. One is buy one more laptop and install Linux in it and install your application and test it. This is one way around. The other way around is that remove your Windows 10, install Linux and do it, right?
Yes.
You think this is a way that we can do it?
Yes, we can do that.
Okay, this is fine. But your project is only going to last for 1 or 2 weeks, and why do you want to wipe off your Windows 10 operating system and then install Linux? Basically, without virtualization, this is the scenario. But with the virtualization, what happens is that I'm just rubbing off these things.
Okay. Oh, we can install some virtual box.
Yes.
Okay.
So on your Windows thing, you install your hypervisor here. That hypervisor is nothing but your virtual box or VMware workstation.
Okay.
On top of hypervisor, you install your Linux. Now it's not only one instance, you can install multiple instances within one single hardware. You're able to do it. So you're able to save cost here, and you're able to save time, and you're having your project ready. This is happening because of this hypervisor. So in our homes, that is, when we're talking about softwares, we have two versions. One is home edition and enterprise editions. In home kind of thing, we use VMware workstations, Oracle virtual boxes, KVMs. But in production, they don't use this. They use Zen. They use ESXi. They use Hyper-V. Okay, these are the vendors. These are the vendors who is going to support all these things. Okay. With these softwares only, you will be able to install virtual machines. If I don't install this hypervisor here, my Windows 10 doesn't know how to install a virtual machine on top of it.
Okay.
Clear? So this is actually going to reduce the cost to the organizations. Instead of running, if you're running multiple servers for one application, multiple applications can run on one single hardware now because of this virtualization.
Okay.
Okay. So now to have a cloud environment, your servers has to be virtualized. Without virtualization, you cannot talk about cloud. There is no concept called cloud without virtualization. Clear?
Okay.
So these virtual machines, whatever we are talking about, so we call this as a virtual service. Again, what does virtual server has? Virtual server has a virtual hardware. On top of that, we install our operating system and we install our application. And this all complete stack, this we call it as a virtual server, and Amazon will call it as an instance. A virtual instance. We call it, if it is having a Windows operating system, we call it as a Windows instance. If it has a Linux operating system, we call it Linux instance. Clear, guys?
Yes.
Okay, so you just try to work on these things. Try to Google yourself with the hypervisor, what is a virtual server, so that you actually understand this. So I have given the basic understanding. Once you go back and read, you should understand things.
Yeah, sure.
And in EC2, that is Elastic Compute Cloud, we use different services called auto scaling, Elastic Load Balancers, and EBS volumes. So these are things, we'll discuss all these things individually now. And for networking part, we use Virtual Private Cloud, which is a service which will allow us to install networks, create our own set of networks. And Route 53 is a DNS service. Okay. So what is a DNS service, guys? Domain naming system or domain name service. What does it do? No idea. Okay. So we know Facebook.com. Gmail.com. Or any other website you take. We remember only names, right? We remember the names of your domains. Guys, do you know that this names doesn't work in the back end? Every name is associated with the IP address. Are you aware of this thing?
Yeah.
Every server is associated with the IP address. Without IP address, you cannot have your web server running. So, how many IP address you can remember now? So Facebook has a different IP address. So every time when you're logging, you cannot open up your browser and put Facebook IP address, right? It's very difficult. It is very easy for me to remember a facebook.com rather remembering my IP address. Okay. A different example now, just to make you understand. I have my phone book, or I have my own brand new phone, and my phone has got around 500 contacts. 500 contacts is what I'm maintaining in my phone book. Guys, do we remember all these 500 telephone numbers?
No.
We cannot remember all the phone numbers, right? But what we do, we always save their number with the name. Say Mahesh, Swati, or Abhilash, Abhishek. So instead of remembering their names, I go to my phone book, I just search for name, so that will shortlist me, and I'm able to call them. So I don't have to remember the IP address here. I don't have to remember the number of his guy, or else I should remember only his name. So who is doing all these things here? My phone is doing it. But in terms of our services, our IP to name to IP resolutions are taken care by a service called DNS. DNS maintains every record just like our phone book record, which says that, okay, facebook.com. Okay, facebook.com has an IP address called x.x.x.x, or gmail.com has an IP address called y.y.y.y. This is an IPv4 address, that's right, I'm given 4. So like this, so if you open up your browser, if you know IP, don't type your facebook.com, you just put in your browser, say x.x.x.x, it would open and give you your Facebook account login. So that's how this functions. So all these name resolutions, name to IP and IP to name, are taken care by your domain naming system. Clear, guys?
Yeah.
So we have lot many DNS servers all across the globe, and they maintain all these records and all. That's how DNS functions. So MS1 is also has such DNS. We call it as a Route 53. Clear, guys?
Mm-hmm.
So before we go ahead with this remaining topics and all, I want you to guys remember whatever I said so far, and please work on the concepts such as virtualization, and understand the DNS services, understand physical server, understand virtualization, make sure that there are different types of virtualization, and make sure that you are ready by tomorrow with those things. Okay? Because going forward, these things are very required to understand the other concepts. Okay?
Yes, sir.
So tomorrow we'll meet, and you guys will be ready with all these terms what we have discussed so far, and you'll do your work on it, and tomorrow we'll meet and see the remaining classes, remaining topics.
Okay.
Sure.
Okay, guys. Yeah.
And is it possible to upload the videos?
Yes, I'll do it right away. I mean, by the time you wake up, you will have it.
Yeah, sure. Thank you.
Okay. Thank you.
Thank you.
I think it's better to send like tonight for us, like.
That's what. By the time you wake up, because what happens is that the conversion of video would take time,
Yeah.
around 30 minutes or 45 minutes.
Oh, really?
Yeah, understood.
Okay.
So it's not instantly. It takes time. So by tomorrow you'll get it.
Okay.
Okay.
Yeah.
Thank you, guys. Good night.
Thank you. Thank you.
Thank you. Sure.